As we want to learn about comparing fractions, the first and only principle you always want to keep in mind is that whenever you are talking about comparing two quantities, any two quantities, you always have to bring them to the same baseline. Only then you can compare it, right? And that fundamental principle is what we are going to apply when we are going to compare two fractions, okay? So let us take our first example. In this one, my two numbers are 3 over 4 and 7 over 4. Alright, these are two fractions and I want to find out which one is bigger than the other one. Okay, so the first thing I am going to utilize, the principle is that whenever you are given two numbers, always try to find out, do they have same bottoms? And you will find many times it is available straightforward to you, just like what we have in this case. You have two fractions, 3 over 4 and 7 over 4. They both have the same denominator, right? 4. And the moment you have it, the task becomes very easy because all you're left with is to compare the numerators. And whichever fraction has the bigger numerator is the bigger than the other fraction. So in this case, 3 is smaller than 7. Hence, 3 over 4 will be smaller than 7 over 4. You could always argue it logically as well that when you divide an object and that object is of 3 units, you divide that into 4 pieces and at the same time you take another object and that object has a size of 7 units and you divide that into 4 pieces. Which one is likely to be bigger? Of course, you will see that the one that had a higher size to begin with is going to be bigger than the other one. And that is the concept we are talking about. Same bottoms, meaning same denominators. When you have two fractions with the same denominator, the one with a bigger numerator will be bigger than the other fraction. Okay, so that's one. Sometimes you will get fractions that have the same tops, meaning their numerators are same instead of the denominators. So let's take an example. Here I have two numbers, 3 over 5 versus 3 over 7. Now you tell me which one is bigger than the other one. Keep in mind, you do not have the same denominator anymore, right? You do not have that. You have same numerator or the same tops. And when you encounter such fractions that you have to compare, look for which fraction has lower denominator, okay? And the one with the lower denominator will be bigger than the other fraction, right? So in this case, I have 3 over 5. 5 is lower than 7, right? So that means 3 over 5 will be bigger than 3 over 7. And at the same time, you could argue this logic of 3/5 bigger than 3/7 in slightly different words as well. If you break down 3/5 into two pieces, you will say that 3/5 can be written as a product of 3 times 1 over 5, right? We could do that. And 3/7 is a product of 3 times 1 over 7, right? Now you see, you have quantity 3 of some object, right? And you also have quantity 3 of some object, right? The first object that you're dealing with is of size 1/5, right? Meaning you take one whole circle and you divide into 5 pieces. That's what will give you 1/5, right? And you take the same whole circle and you divide that into 7 pieces, you will get 1/7 of a piece, right? So 1/5 of a piece is bigger than 1/7 of a piece, right? Or in short, you can always remember that when you have two fractions with the same numerator, the one with the lower denominator will be bigger in quantity, okay? But sometimes you may not be that lucky that you get either the same bottoms or the same tops. Sometimes you might come across two numbers such as 3/5 and 7/8. These are 4 different quantities. Neither the tops nor the bottoms are the same, right? So what will you do then? It's very simple, and there is a quick way of converting these two fractions into something very easy, and that is called cross multiplication. What it means is that you take the bottom of fraction 1 and you multiply that with the numerator and denominator of fraction 2. All right, and likewise you take the denominator 2 of fraction 2 and you multiply that number with the numerator and denominator of fraction 1, right? And as you do so, what you really obtain is 3 times 8 is 24 and 5 times 8 is 40, right? And on this side, you will get 7 times 5. That becomes 35 and 8 times 5 becomes 40. Bingo. Now what you have is two fractions that have the same denominator, right? And these two fractions are equivalent to their original fraction, right? We haven't changed anything. We have simply brought them into slightly different form. The ratio hasn't changed at all right? Now your task is very simple. You have two fractions, same denominator, and the one with the bigger numerator will be bigger in quantity, right? So in this case, 24 over 40 is less than 35 over 40, okay? So this technique is called cross multiplication. You might want to remember it, cross multiplication. All you are doing is using the concept of cross multiplication to bring two quantities to the same bottom line, okay? But sometimes, instead of these straightforward fractions, you might come across some mixed numbers. Let's say I take two mixed numbers, 2 1 over 4 and 3 1 over 5. What will you do then? Now you have none of these conditions, right? So the task, I would say, in my mind is even simpler than all of these because you have two mixed numbers, okay? Compare the whole number part to begin with. In this case, I have 2 and in this case, I have 3. Clearly, 3 is bigger than 2, right? So you have clearly the fraction 2 bigger than fraction 1 by one whole unit. At this moment, I won't even bother comparing the fractional part because no matter what you do, the fractional part is not going to beat the whole number part, right? So in this case, I could very clearly say that 2 1 over 4 is less than 3 1 over 5, okay? But what if someone says that? What if I do not get that lucky that the whole number part is always bigger? So what you do then, let's say I have numbers 2 1 over 4 and the second number is 2 3 over 4, okay? Well, in this case, the whole number parts are the same, right? Identical, no issues there, okay? But in that case, what you do is you compare the fractional part because the whole number part is the same. Simply, right? And when you are left with only the fractional part comparison, you are simply going to check one of these conditions, either the same bottoms or the same tops. If they do not have any of those, you use a cross multiplication and then come to your conclusion, right? Simple enough. In this case, I'm seeing that 1/4 has the same bottom as 3/4. So clearly 3 is bigger than 1, right? This fractional part, the numerator of these two fractional parts, right? So in that case, my decision becomes very simple that 2 1 over 4 is less than 2 3 over 4. So this is how you're going to compare fractions. That the trick is extremely simple. Don't get frightened by the 4 quantities that you have to compare. You always check one of these conditions. Do they have the same bottoms or do they have the same tops? If none of these conditions exist, whatever fraction you have been given with, use the cross multiplication method to bring them to the same denominator, just like what we did here. With that, we will pause here and then we will go to our next lecture on performing mathematical operations on fractions.